Hi everyone, can you guys hear me? Nice. Is it only one viewer? I think if it's Prismax, that's enough. One viewer is enough if it is Prismax. So what I will try to do is I am recently practicing some problems in some range. So I'll try to do the same practice here, but then if midsems are going on, skip my stream, watch them later. Don't waste your time, okay? Wait, where are you people coming all of a sudden? Yeah, Mohit, long time no see. You have not been attending my streams at all. But then it's glad to that. What can I do? Yeah, even you haven't joined in a while. Oh, I see. It's my fault then. Sorry. so, so is clarity still bad? I don't like it. Hi Shive, I am good too. So we will try to read some problems. Okay, okay. I will open my WhatsApp too. We'll try to read some problems. Why am I itching here? We'll try to read some problems. Now, okay, that's nice. I hope clarity stays well throughout the whole stream. Okay, there is a blog, right? I want to try some 26 to 29. I will give that a shot too. But before that, I want to try some whatever I do, try. Okay, we are here, right? This thing. I know that, but before that, I want to read some problems. I want to read some problems. Okay. So we have a competitor coming up. He's international grandmaster. He has been international grandmaster 2679. Can I ever cross this rating? I can't. I'm a loser. He is also streaming, absolving. He's quite famous, I think. But I have to cross this rating at least sometime, right? What the fuck? Is clarity bad? Is it the internet that's bad? One minute, I'm getting a call. I have to answer it. I'm muting myself, okay? Okay, I hope internet is fine. So, first I will do what I want to do, and then I will try that blog. I will try And then I'll try the blog. I'll try. Okay, now it's better, right? Now it's better, right? So yeah, so let's read some problems, and then I will try to read the short statements, and then I will try to see the lead code problem too. Okay, let's just read some problems that I want to solve. Okay, so I have a contest tomorrow. We have a contest tonight too. Do well, guys. Contest, you guys should do better. So I will try to solve in this. I have solved this yesterday, so they should not be too difficult, right? So we'll try in this range only. We'll try to open problems, several problems, and then read them. Okay. MST in modulograph. Okay, these are a bit difficult ones that I have seen long back. Let's still try them too. No getting scared. So let's try to read all these problems. One, two, three, four, five, six. Okay. I have read this problem long back, but then let's again try it. I was not able to solve this long back, but then let me try again. Okay. I only solved this one. What is ICPC for gold? Is it a contest? See, Indians with their placement mindset, they are nowhere going for gold. All they wanna do is just get placed. They don't like problem solving. Probably they don't wanna do better things. They don't like that. With that mindset, I think we can go nowhere. Okay, let's try to read these problems before going for gold. They look scary, right? I think I have read this problem too. That's why I'm not able to try it much. But then still, let's give it a try. Let's read the problem and let's try to give it a try. Okay. This sequence C of length K. The only difference between this version and the version is sum of n doesn't exceed 5000. F1, G1, F. Let's try reading this problem, guys. Reading problems, even not solving, helps us. Okay. The difference between the versions is that so harder version is much higher than 3000 probably. That's why I only have G1, right? I'm not seeing ratings because it's unnecessary. All problems are same, right? Yeah. So let's read this one. For an so here we have n less than or equals to 3 and sum of n does not exceed 5000. We have both of them, okay? For a non-empty sequence C of length k, define f of c as follows. So for a non-empty sequence of length k, we have f of c, which means turtle and pig are playing a game on a sequence. I remember fucking up this problem. I remember fucking up this problem. I don't want to solve it because it only depends on the first value and the last value. But then I I kept trying something weird in this contest. It only depends on the first value and the last value. But then I fucked this up in the contest, and then I saw somewhere that it only depends on first value and last value. So because I have seen this problem already, it's not that great problem. I'm skipping that. I have tried this thing, but then so I know this problem. So let's not try that. Okay. It only depends on first and last value, but then to get that in contest. So the first thing we should do is we have to solve f of c, right? and then we have to find the value over all subarrays. Okay, that's the problem. But then I fucked it up because f of c only depends on c1 and ck. But then I was not able to find that in contest. Okay, so problem is not too complex. First you have to work on f of c, and then you have to somehow work on counting that. Okay, so this is not out of anyone's reach if you can somehow apply logic on f of c. Do we have viewers still? Yeah, bro. They will do that, but I will make you guys go to ICPC. I'll make you guys go to ICPC Gold and everything. I'm just joking, because ICPC you guys can do if you really try with your thing, and then ICPC World Finals is not too difficult because getting top 15 or top 12 would work in somewhere. Okay, now let's read this problem. I hope I haven't read this problem before. Okay, the difference between the versions is that in this version n less than or equals to 2000 you can hack only if you solve all the versions of the problem. Serval, this name is famous, has a magic number k. We call an array R colorful if and only if the length is R. If and only if the length of R is k. So we call an array R colorful if and only if the length is R, length is k, and each integer between 1 and k appears exactly once in R. So that doesn't that mean it's just a permutation of k? Okay. Given an array A consisting of n integers between 1 and k, it is guaranteed that each integer between 1 and k appears in A at least once. You can perform the following operation on A. Choose an index size swap ai comma ia plus 1. So we can just do one swap, okay? Any number of times, okay? Okay, we don't know any number. Find the minimum number of operations needed to make at least one subarray of A colorful. It can be shown that the. So it's a good problem. It's a good problem, right? We can do swaps, and then we want some subarray to be permutation of k. Okay, so we have to think, okay, to make. So the problem gives you something. Given an array, you can only do swaps. What are the minimum swaps you can do to make some subarray as a permutation? So when you see a problem, you should not look at the problem in a way that you think, okay, some random idea comes to me and then the problem gets solved. You have to see the problem as a puzzle. Now you have to form a proof that, okay, this procedure, minimum number of operations to form a subarray. You have to see the whole. You should not try random ways. Uh, uh, you should not try random ways to just do something and hope that's optimal. Okay, you have to see the problem for what it is. What it is now, you have to somehow get a procedure and prove that this this is the best way. This is the minimum number of operations to get over all possible subarrays. Like you can make that klen subarray here or here or here or anywhere, right? So once it is here, you should be able to say what is the minimum number of subarrays. So maybe we can try to brute force that. Okay, where we form that, we can try to brute force that. Okay, where we form that, we can try to brute force that. So let's see. So you guys, did you guys understood this problem? Have you guys understood this problem? Focus on the stream, bro. You'll find your path. Okay. Have you guys understood the problem? Are there viewers? Are there active viewers? Prismax, what about you? If you have understood the problem, we'll try for 5 minutes. We'll go to next problem. Okay. Mohit Kumar, push yourself, guys. Try. You don't go for gold without trying harder problems. What are you guys understand? Okay, now let's try to make some statements. So now let's try to make some statements. Okay, can we brute force that subarray and find the answer? Okay, so you have array A, size n, minimum swaps to form a subarray of size subarray that's a permutation of 1 to k. So this is the problem. If you are fixing this, what can we say? Array A is there. We are fixing indices of, so let's say at index I, you're going to make that permutation. So how to make that permutation in this is our what we have to try now, right? So some elements already appearing at least once here, some are not appearing at all in this subarray. Our goal is to bring one occurrence of each into this, right? It just shows we have 5 viewers. Like the video, guys. We need more viewers too. Okay, we will try the problem. So till here it's fine. Okay, can we brute force? Probably F1 is probably just brute force. Okay, and now the problem says now you should be able to find minimum number of ways in which you can get everything once into this thing. Okay, so some are repeating. We can only ai comma ai plus 1. You can only swap adjacent things, and then you have to prove that these are the minimum number of moves. Give importance to everything. Okay, should be able to prove to that. Okay, these are the minimum number of moves to make them inside. Okay, so now we have few nearby things. Let's say we have few nearby things. We have few far away things. Okay, so if you think about the problem, let's say you have one here and one is not in between this. You have one more one here. Is moving closest one inside is better than moving this one? So what does that mean? This one is never coming inside finally, but this one is coming inside. So that means that one has came till here and then that one has crossed this one and then it went. But instead of that, you could have just moved this one, right? Instead of that, you could have just moved this one. So you guys have to think, if there is a one here, if this one is closest, if this one is, but if this one is closest, let's say this one is a bit far, that doesn't guarantee that taking this is always good. Why? Because we are not able to make a statement. Maybe there are more things here. Maybe there is 2 3 4 here, so that everything can come together or something like that. So we have to be very careful in logic. What you can say, you have to say. What I can say, if there are two ones here, instead of this one coming here, instead of this one coming here, just this one going would have been better. That is true. right? Just this one going would have been better. How can we say even if something from here comes here, this one not moving would have been better? If something from here comes here, this one not moving would have been better, right? So this one is better. And now let's say we are able to see, we have to use logic, whatever we can use we have to use. Let's say we are able to know what all indices, what all 1 to k that comes inside. What can we say about this thing? Okay, what am I trying to do? What am I trying to do? Let's say this is our subarray that we are trying to look at. But then finally what happens? We will have 1, 2, 3, 4 up to so on k in this subarray, right? Some might have been already there, some might have came from outside, some might have been just here. So if we know these indices, can we know the answer? Is one thing we can think of, right? If we know what are the indices that are finally coming inside. So we're just trying to logically say whatever we can say to understand the structure of the problem a bit more, okay? Do we have viewers? Try. I want at least one person following. It's either Mark or Try, Mohit, Prismax, anyone. Yeah. So let's say if we have these things, can we say answer to this? Let's think of that. Okay. So everything else goes outside. All these things comes inside this thing. So what would be the minimum answer? So all these things should merge, right? All these things should merge. All these things should merge. Them crossing over each other is bad. That's not beneficial at all, right? Them crossing over each other is not beneficial. That is true. Them crossing over each other is not beneficial. If you see this thing, I think at any point them crossing over each other is not beneficial. Why? Because all of them are same. All of them are same now. Their values doesn't mean much to us, right? Their values doesn't mean anything to us. They're all same. And then they're all coming together in minimum. So moving them is always bad. After moving them, there is no change again. They are same things again. So why would you move that? You won't move them. So now what happens if you see this big subarray? All these blue things are going to these positions and remaining things are coming outside. So what is the minimum number of moves to do this? Okay, what is the minimum number of moves to do this? We can try to think about this. This values doesn't matter now. These are just some blue things that are coming inside, and these things are going outside. What's the best things we can do? Moving this till here and then moving this two till here, something like that. We have to see. Okay, okay. The same goes for orange things too. Moving among themselves is also bad for them, right? Moving among themselves is also bad for them, right? Moving among themselves is also bad for them, right? Because there is no need to do that. Why? Orange things are same, they're anyway going out, so there is no need to do that. So we are just fixing, okay, what if I know the indices of 1 to k that comes finally inside? Okay, see how you have to use logic is you have to try to say what you can say. You have to do what you can do. No topic is going to save you here, right? You have to use logic. So let's try to look at this. See, these statements are being nice, right? Okay, we have only two colors now, things that come inside, things that go outside. So you guys are able to follow, right? I'm asking it again. Fuck, what's happening? Not able to flex my muscles. Yeah, nice. So if we fix the indices that are coming inside our subarray, if we fix these things, then we have, so let's say we are fixing that this is our subarray that we are trying to get into, but then we have few indices, I1, I2 up to so on. These things are coming inside, let's say. Okay, these things are coming inside now. Them, all of them are same color because the goal is them to come inside. The goal of the remaining things is to just go outside. Okay, yeah, only that matters. And also the relative ordering doesn't change at all. It's also true that the relative ordering doesn't change at all, which means for every blue, you know their final position. For every orange, you know their final position, which means, so uh, we only swap blue comma orange, which means relative ordering of blue doesn't change. Relative ordering of orange doesn't change, right? And in one move, we only swap a blue or an orange. If relative ordering doesn't change, for each color, for each ball, let's say, we know exactly where it goes finally, right? You guys are there, right? If relative ordering doesn't change for each ball, we know exactly where they finally go. Okay, we know exactly how much this moves. It moves to here. Sorry, it moves to here. This one moves to here. This one moves to here. This one moves to here. Right. We know exactly where they go. And now if you notice, this moves at least this much. This moves at least this much. Right. So is that the answer? Is that the answer? Absolute value of this minus this, is that the answer? Is that the answer? So, to conclude that, we should answer, as long as we don't have what we want, can we swap a blue and a orange? This is our question. As long as you don't have what you want, means not all blues are inside the box, means there is an orange. You can swap that orange with a blue for sure. Okay, if there is a blue inside, you can swap that orange to that blue. If there is a blue on this side, you can swap that orange to the blue too. So probably true. We can always swap that. We can always swap them. So what is the answer then? What's the answer? What does the answer seem to be? What does the answer seem to be? So if you see again in some other way, for these things, all of them should go outside, right? All of them should go outside. But then them going on this side is bad because them going on this side is bad because then they have to cross more things. Them going on this side is good, right? We can see that in this way too. If you see in that way, all these things has some weight one of going outside. All these things has some weight two of going outside. All these things have some weight three of going three of going outside. And for this again, for these things again, it's just weight one of going outside, right? So we can write the answer in many ways. We can write the answer in these ways where these things with one go, these things with two go, these things with three go, these things with four go out. Or we can write it in some other way, or we can write it in some other way too. Okay. Now let's try to apply more logic, a bit more logic. Should I read some other problem if we can solve this? Because we cannot get stuck on one problem. See, all top people will read all the questions before attempting one because they know. What background? So let's try some more time. If you're not getting any points, we'll skip the problem. Okay. So now we have to apply a bit more logic. Okay. See, maybe we can brute force this thing. Maybe we can brute force on the first and the last. Maybe we can brute force on the first and the last blue things. That this subarray, this big subarray, is what you're trying to converge into. Now we can brute force on even more things, is what I'm trying to say. Okay. This thing you want to converge. Let's say this thing you want to converge. Let's say okay. But how do you apply that these blue things are all unique? Like unique in the sense these blue things should form a permutation. How do you apply that? But at least one thing you can say. For these things to be blue, at least one of them should be here. That's what the problem given to us is. At least one of the occurrence is there. So if at least one of the occurrence is here, I think seeing yellow things going outside is better, probably. Right. And now what can we say? Now what can we say? If this value is 1, okay, now we have a mid value. Okay, we have a mid value. If this value is 1, you cannot have 1 here. Why? If you have 1 here, instead of making this one, you will make this blue as 1 and then you will make this as orange, right? That depends on mid. Mid is being a pivot here, okay? Mid is being a pivot here. We're going somewhere. Stay, guys. We can solve problems. It's not working, guy. It's not working, bro. It's not working. Sorry. So if you see that, we're trying to make more statements. We're trying to because we have to worry about the numbers also, right? We have understood structure of the problem in some sense. Okay, it's like mid matters because this thing's going that side is better than this thing's going this side, right? And if this thing is going that side, it's crossing at least these many blues. If it is going this side, it's crossing at least this many blues. So mid matters a bit. Okay, mid matters a bit. And if you fix mid, I think brute forcing on mid seems more beneficial now. If you fix mid, okay, if you fix mid, what can you say? If you have a 1 here, you cannot have a 1 here at all. Why? If this blue is 1, because if this was 1, orange 1, instead of making this as blue, you'll make this as blue because this is made. Now it became more optimal. See, everywhere what we use is we use these exchange arguments. In trying to find greedy things, you use exchange arguments. Like exchange arguments means, okay, can I exchange these two and then can I make it a bit better? That's what we do. So you guys should just get better at using logic, get better at using such arguments, using such seeing something, making some statements. That's all problem solving is about. And you guys should be become better at thinking a bit more deep, trying to push yourself to think harder, trying to push yourself to think deeper. These are the things you have to learn. It's not knowledge. It's not like knowledge or some topic. Okay. So if you fix mid, then we're able to say something about the value. See here, if you fix this to be the middle thing, you're able to say something about the value. What? The one you take, it is the nearest one. You're able to say such a nice thing now. So now, if you fix mid, you know potential candidates for all numbers. You have potential candidates. I think even this I was able to know intuitively in the very beginning itself. But if you fix mid blue, you can know potential candidates because the closest one is a potential candidate on this side, and also on this side you have a closest one that's potential candidate. So if you fix this thing, okay, whatever that value is, if you are fixing the middle one, if you're fixing the middle one, see, once we know the structure of the problem by assuming we know all the indices, then we are able to go further and say, okay, fixing this seems better because after fixing this, I can make more logical statements, right? Now we have potential candidates. Okay, is this clear till here? So that will be lost then. Nah, I want that. I want that to happen. I'm doing that voluntarily. I'm using it here also to represent a group. So I want that. Okay. That was cool, bro. I thought like it's clear. I thought like it's cool to happen that. So where are we? Till here, it's clear. Fixing mid seems good, right? Fixing mid seems good. So now if you fix mid, you have potential candidates. Is it clear that now we have potential candidates? If we fix mid, see, we came from some many complex things to now for each thing it's either this one or this one. It became so simple now. We have some potential candidates, right? I think this is good progress. I think, see, now I think this is the way. This is the way because if you don't fix mid, you cannot have anything. But now, how complex is it? If this becomes too complex, maybe then this is not the way. But if this getting simplified, then that's the way. Because we have one here, we have another one here. If there is only one, then that must be taken. If there is only one, that must be taken. If there is only one, that must be taken. But then if there are some things or two, let's say you have two twos, one two here and one two here. Now we have to be careful, right? We have to be careful. We have to be careful. We should also finally make sure that we choose half things here and half things here, right? So that this will be mid. That seems not that easy to choose half things here, to choose half things here, right? But still, let's try. Still, let's try. So now, for few things, we have two options, right? For few things, we have two options. For few things, we have two options. And can we somehow brute force all these things and somehow cover it? Is it possible to somehow brute force all these things, like all these possibilities? If you don't take this one, you must take that one, right? Can we see? Can we? Okay, there are two possibilities. Can we find a best greedy way to choose these things among two possibilities? Can we somehow choose what possibility is better? If you are trying that way, we have to represent our cost in a better way. We should be able to represent our cost in a better way, right? Because whatever is here that takes these many values will contribute to that cost. For this, I think rather than seeing this will go these many times that side, we can see for this we have this much cost because all these things cross that once. For this we have number of LOs cost again. For this we have number of LOs cost again. For this we have number of LOs cost again. For this we have number of LOs cost again. So if you choose this thing, what's instead of seeing how the weight of yellow, let's try to see in terms of blue, because if you choose this blue, this much cost will be added. If you choose this blue, this much cost will be added. All these yellows must cross that. If you choose this blue, all these yellows must cross that. So what is the cost of this thing? Number of oranges number of oranges plus number of not chosen blues is the cost. Number of oranges plus number of not chosen blues is the cost. So when you have two twos, you may not choose this two, then that will become yellow, right? Then that will be added to everything. Can we brute force something else? Can we fix something else and solve the problem? Can we somehow fix something else? Like number of blues still here. If you know number of blues still here, can we proceed further? Does that make it n cube? Whatever I'm trying. It's an easy version, so let's try a bit more. Okay, let's try a bit more. It's true that everything else, all these things should leave that side, all these things should leave this side. That's true. We also have potential candidates now. If you fix this thing, we have potential candidates too. So now we have to think. Let's look at this thing itself. Okay, let's look at this thing itself. This is the first blue, right? Let's say this two is this is the first thing, right? But then here it may not be the first thing. But if that's also a first thing here, then is choosing the nearest thing better? or choosing the farthest thing is better? Choosing the farthest or nearest? We have to think a bit. What is the trade off between these two? What is the trade off between those two? See, we can also use some exchange arguments that finally, finally, when you swap this two with this two, the cost should decrease. The cost should not increase. You can use that too. Let's say you have your optimal. Let's say you finally swap those two. Instead of choosing this, you choose that. Still, the cost should not decrease. If that's the optimal, how simple is that to use? Choosing this instead of that, what's the difference? Let's try to find something. Maybe we can brute force something. Maybe we can. Let's try to think a bit slower. Let's try to rest a bit, okay? Maybe I can eat a chocolate if I have one. We will read one another problem. Let's give 5 more minutes to this and then let's go to another problem. Fixing this doesn't seem that simple. But then it makes sense because these things must go that side. I'll come in a minute. I have to wash my hands. Let's think a bit more. Let's try to understand the problem a bit more. Maybe we are missing something, right? Let's try to give it some more time. Now we even have potential candidates. But what do we have when we have two twos? We can make one of them as yellow, and we have to decide which one. Making which one as yellow is best for us. And you can use O of n because we are fixing mid to decide this. What can we say? Can we say something about the closest blue? Can we say something about the farthest blue? You have to see. One thing is for sure. All the things that has no choice, they must be taken. They must be taken. So we have few fixed blues already. If one is alone, you must take that. Something else is here is alone, you must take that. Now you have this choice for this two. Right? You have the choice for the two. So let's say you have all the fixed things. Now you're looking at choices. choices. Either this or this. Either this or this will go blue. Either this or this will go blue. Is there a greedy way to choose them the best? Is there a greedy way? That maybe, right? Let's try a bit. So what's the cost of this blue if it exists? Number of orange before it plus number of blues that changed into orange, right? Number of oranges before it till from here. That's the cost. So if 2 has two possibilities, like here and here, let's say we also have added blues which are fixed blues, like okay, this blue, only one, this is a fixed blue, we have added that already. Now we have choice. Let's say this is the first blue with choice and this is the first blue with choice. Okay, if you choose this, if you choose this blue to become orange, what happens? So for this blue, number of orange before it, for this blue, number of orange before it, because this is the first blue with choice, we know that value. For this blue also, we have number of before it, we know that value. But if you make this first blue as orange, first or changeable blue as orange, it will increase cost of all the blue things later. It will increase cost of all the blue things later. Right. So number of orange before and number of blues later, that seems to be affecting if this, what happens when you change this to yellow, right? Number of oranges before and number of blues later is the change. If this goes becomes orange and this becomes red, green, this becomes blue. So if this blue becomes orange and if this orange becomes blue, what's the difference? Number of oranges here plus number of blues later. This seems complex, but then again we have to apply the restriction that total size is. Now I have a question. I have a question that if number of sides are not equal, that means we are moving more things on this side unnecessarily, right? Let's say number of things are not equal, but but that's the minimum you can move. That's the minimum you can move. Let's say that number of things are not equal, but that's the minimum you can move by moving things. These things left side, these things right side. Is that, would that still work? I don't know. It's rated. So we are not getting this, guys. Let's try to read another problem. Let's not waste time. We can come back to this later. There will be easier problems. So let's try easier problems. But maybe we have gotten it. Or maybe I will come back and solve this. Can I ignore sizes being equal on both sides? If I ignore sizes being equal on both sides and still get minimum summation somehow, that must be equal, probably, right? No, that may not be equal. They may not be equal, but then it's like fixing this, everything gets attracted to that. And then we are trying to choose minimum things. Okay. Let's ignore the sizes being equal. Now, will the optimal be covered at some point? Optimal has a mid, and everything is drawn to that. Right. So you can ignore sizes. You can ignore sizes here. You can ignore sizes. Why? You're trying to get everything towards this. You're trying to get one occurrence of everything towards this, but you don't care about sizes. Still, optimal is being covered. How? For optimal, there is a mid, and everything comes towards that. Right? So we can ignore sizes. We can ignore sizes being equal. So that makes it a bit simpler. We can ignore sizes being equal, but we have to say the minimum cost to make everything towards that. So we can ignore sizes now. So now if we have two things here, it's number of orange here plus number of blues is the cost of this going from here to there, right? So finally, whatever the arrangement you get, for that arrangement you can say number of oranges here plus number of blues later of chosen one is less than number of oranges here plus number of blues behind of the non-chosen one. That you can say. Finally, if this is the optimal, fixing this, we need not worry about the sizes being equal, because instead of seeing the sizes being equal, you can see the same thing as mid. Everything is getting drawn to mid. What's the minimum? For everything, at least wants to get drawn to mid. Right? You can see it like that. For this, you can see this as everything half getting drawn to that. But instead of that, if two things are getting optimal, optimal is everything getting drawn to mid, right? You can see optimal as everything just getting drawn to mid instead of seeing sizes being equal, because sizes will automatically be equal. So we need not worry about size, because if this size is not equal, but then optimal for optimal sizes are equal, when we go to the optimal, then I mean, instead of seeing equal, we are focusing more on everything being drawn to this. What's the minimum cost? That happens for this. Okay, everything being drawn to this. What's the minimum cost? It happens when sizes are equal, but we need not care about that. Seems weird, seems wrong, but I think we need not care about that. We can see it like everything of one occurrence getting drawn to that. Because what does myth say? It only says orange things leaves like this and like this. That's it, right? So now number of oranges here plus number of blues later. Can we find something greedy? Can you hold me? Do we have viewers? I don't know how people can see this. See, we are going for all myths. That's true. We are going for all myths. Everything's drawn to here. But we have two choices for few things. What's the best thing to choose is our question. When we have two choices. No, bro, no Java. I can do in Java, but I am not doing now. Let's try some more time. Prismx, or you guys try to take a pen and paper, try to think too, because it's not something only I can do. Anyone can do. If we can try. Well, maybe not brute forcing on mid. Is that better? Is fixing the lost blue that remains, is that beneficial in any way? Okay, if you fix the lost blue that stays, okay, all the oranges will cross this. What are the remaining blues matters? Okay, if you fix that, all the oranges. But then if some of them becomes orange, they can leave it. See, the problem just became as complex as you have just made so many myths, one occurrence of few things, two occurrences of few. Just two occurrences are enough. More than two occurrences are useless anyway. Can we say something more? If this is this, and then if this is the first occurrence of something, and this is the first occurrence of something, what does that mean? All of these are same values, right? Because all of these yellows are same value v. Why? If they are not v, then you can immediately choose something else, probably, right? I mean, that would have been blue if it is not v, because that would be first occurrence of something, right? So you have all these myths, and then you get first time something else, and then you get something else first time. Now it can have mid or v or one, and then you get something first time. It's being time waste. Let's read another problem. Interactive. Interactive may be good, right? Let's try this well. Let's try this well. Interactive problems are good. We will come back to this problem, guys. Thinking improves you people. It's not solving. What's the line between thinking, getting something, not getting something? Nothing, right? Just because you solve doesn't mean you have improved, or just because you haven't solved doesn't mean you haven't improved. We'll come back to this later, maybe in this stream itself. Let's read this too, because title is reading problems, not solving them. You guys should be able to put lot of effort without expecting anything back. Otherwise, you can't achieve, not achieve. I'm seeing the trespassing girls. You should be willing to put a lot of effort without expecting anything back. In most cases, the jury has a string S consisting of lowercase Latin letters. Now let's try to understand this problem. The string has an odd length that does not exceed 99. Okay. The string consists of characters only A and B. I'm trying to think of other problem too. Okay. Only A and B. Length does not exceed 99. There is also a string T which is initially empty. Then modulus of S steps happen. During the ith step, the following event occurs. First, the jury tells you the character SI and appends it to the end of string T. In the ith step, it tells us that and then it appends. Then you may swap any two characters in T or do nothing. Oh, see this thing. Nice problem, right? What does that say? There is a way. Just by doing this, you can make it a palindrome. You don't know S. You will keep knowing S one after the other. But still, you can make sure that's a palindrome. We can go from behind. If we are able to make the string T a palindrome, one step before, what would it have been? So, maybe we can apply more logic here easily. See, we are leaving previous problem because we are getting stuck. We are not able to apply any logic. Maybe we have to see it in a bit different way. Right? I think if you can brute force on number of blues chosen here, would that work? But then having two twos is wrong, right? We can apply logic here. We can apply that. How the fuck can length help us? It is odd to. See, so what should be our way to proceed so that we will be able to make T a palindrome after last step? See, if you look at the problem, when Sn is added, what T would you maintain so that with just one swap you can make it palindrome, right? Till here it's an even number. What T can you maintain so that after one swap you can make it a palindrome? We're trying to go from behind. only A and B are there. So if there are only A and B, what are the palindromes we have? So we have only, I mean, if it's an even length, then you cannot make, right? A, B, B, you cannot make if n is even. But if n is odd, it guarantees that either CA is odd or CB is odd, but not both. So, with this itself, with this itself, CA being odd or CB being odd, the middle element is getting decided. Fuck. Which means if Sn equals to A, that makes mid element to change. If Sn equals to B, that makes mid element to change. See that? I didn't even do much after waking up. Like the video, guys. Okay. So see this thing. If n is odd, if n is even, it's impossible at sometimes. If n is odd, if CA is odd, mid should be A. Why? If C only one of them is odd. With this itself, if CA is odd, mid should be that. If CA is even, mid should not be that. That means just after knowing the additional information, you should adjust something here. Do you see that? It's like you must do that. So we are able to know how should we maintain it. What is the swap you must do? You must do after n step is known. So now, what is it? We should swap mid element with something. Need not be with nth thing. This we can say. So what do we maintain? What do we maintain if you are for sure swapping mid? If you are for sure swapping mid, I will make it ABA. In this case, we must swap mid. I mean, we don't swap it always, but in some cases we should be able to swap mid. And still, I mean, here our what I mean is what I mean is just because you have to do it in some cases, you should be doing it in all cases because you don't know what comes next, right? Do you get what I mean? It's interactive and it comes later. You don't know what it is. And still you should be able to ready. Okay, if it is A, I'm ready. If it is B, I'm ready. But if it is A or B, it may change mid. It may change mid. If it is B, maybe it will change mid. If it is A, it won't change mid in your case, right? But if it is B, it will change in mid and I have to be ready for that. If I'm having AB, after B comes here, can I make this in within one swap? No, right? We cannot make this with one swap because you have to swap. Okay, you can make this with one swap. You can swap A and B. So what do we have? Let's say we have we have this is n minus one string, right? We have most things matching. We have most things matching. Okay. We have most things matching. We can insert new things anywhere, right? So let's try to always try to so one thing, should we always try to maintain it as a palindrome or not is one question we can think of, right? Or can I just have anything and then once mid comes, from then I will start working. From then, if A comes, if it matches, I won't do any swap. But then if something that doesn't match come, can I save this with one swap? Is the question. So A is here, right? And then B is here. So if there is a here, if there is a here, maybe then I can swap this B with that A and then I will be done. So until mid element comes, these things are fixed. We cannot do much with them, right? Until mid element comes, because they are just them. You swap among themselves, it doesn't matter. Maybe it doesn't matter much. Maybe once mid element comes, like the mid position, and then you're trying to see if A matches, A matches. Okay, but if A doesn't match with this B, can you do one swap and make these two things equal to these two things? Is my question. So, because it is mid and it's not yet final, because it is mid and it's not yet final, there will be all B's or there will be some A. Right? If there is some A, then we can swap this and then we make these two equal to these two. Okay. I still don't know how do we use 99. I don't think 99 will be used logically because it's just for constraints, I guess. It's just for constraints, probably. I think 99 is useless. I don't see logically how that can help. We have more logic here. But if it is this, then because this is not yet final and this is B and also all these are B, we can do this B with this A so that it becomes A and then B. Okay, so again we were able to make these two palindrome. So we can make everything palindrome once we start working from mid until n minus 1. Until n minus 1 you can make everything palindrome without even touching mid. Okay, now you are getting B, let's say. Now you are getting B. So all this is palindrome. All of this is palindrome. All of them are already matching perfectly. Now you have three characters. The first one, the mid, and B. You have three characters. Everything else is matching. So what those three things can be? They can be A, B, A, in which case you are done. They can be A, B. So if first character is always equals to last character, you are already done. But if they are not equal, then the middle can be A or the middle can be B. In both of these cases, you can just swap these two or you can just swap these two and then you are done. So is this a shitty problem? Is it that easy? Is it done? I don't even feel like I have solved anything in here. Did you guys feel you have solved something here? I'll change shirt for no reason. Is this better or not? But did we solve anything here? See, I have used one logical statement. What did I use? Anything that comes before mid, whatever the swaps you do, it doesn't matter. That statement I have used, it's a powerful statement. If you notice, anything that comes before mid, doing swaps on them is not that useful because it doesn't change what existing in the previously, right? So this is a powerful statement that I made. Not too, it's a basic statement, but still it's a bit powerful. And then we can proceed further. So we are done. Bro, we have just solved, but do you see how it got solved if we try with no fear? Do you see that CF analyzer? You're back. It's another day now. Did you go and sleep? See, I'm wearing different shirt. It's another day. I mean, we know every character, right? Once the character comes, we know the character, right? CF analyzer. So my logic is clear. I'm not even touching mid. I'm not even touching mid. When B is there, when A is there and A doesn't match with B, when A is there and A doesn't match with B, I'm just telling if everything else is B, we can choose that B to replace this. But if everything else is A, we'll just change that to this. Because something else definitely exists, right? We are not even touching mid. Touching mid until the end. So our solution is very clear to us. So now I'll just code it easily. But is this the problem? We were struggling a bit for the previous problem, and this problem is also in the same rating range, right? It's in the same rating range. See, CCF analyzer, if you have tried this problem in the contest, If you have solved F problem F along with A B C D E, you would have gotten much more rating. So you're being robbed here. You're being robbed of your potential CF analyzer. Do you notice that? So after seeing that, okay, such a problem exists and people are not able to solve this, you should be, you should understand, like trying to make, you should be like, okay, I will not quit CP until I become international grandmaster or something like that. You should think, because it's that easy somehow. So now, oh, we don't know yen. We don't know yen. We don't know yen. We don't know yen. Okay, now it's a difficult problem. Now it's interesting. Now it's interesting. We don't know n. Ready for all n. See, see, it's not that easy for sure, because if this is the problem, it won't be here. I know that. I know that. But that doesn't mean you use something weird, right? Still, you have to use logic. Still, you have to use logic. N less than 99 may help now, maybe. Maybe n less than 99 may help now. Yeah, maybe. Now, but because now we want a better way. Even if you don't know me, you have to be able to do. Okay, you should be ready for all the sizes. So, so now we can apply more logic. Now we can apply more logic. Even if this is the lost value, so we will receive 0 if it is ended. So we don't know if this is the end. That makes it obvious that we should always be maintaining a near palindrome. What is a near palindrome? After one swap, after an addition and a swap, you can make it palindrome. That's a near palindrome, okay? After an addition and a swap. But it is so whenever it is odd, whenever it is even, because it might end, right? Whenever it is even. I get it. So I get it. What do you mean? Like, if there can be at least three, ignoring any question, we can make swap. I'm not getting it, but then see, size is even. Is this clear? CF analyzer, is this clear? Whenever the length is even, character comes, you should be able to make this a palindrome with an addition and a swap. Whatever the next character is, with a swap, you should be able to make it a palindrome. This is true, right? Let's try to know what we are maintaining by this thing. So we have so many characters, so many things, right? We have so many things. We don't know when we are ending. We have this. Let's say this is even, and then let's say if we maintain something like this whenever we are even. Okay, let's say we are trying to maintain something like this whenever we are even. Because we have too many B's, too many A's, right? So whenever we are even, add an X and you can swap and make this a palindrome. See, the problem would be about logic, but then there may be some randomization we use. That doesn't mean it's more of randomization. Okay, let's try this problem. Maybe one randomization technique I know is like, if there is half probability of happening something, and then you make sure that half into half into half into half 60 times, 1 by 2 power 60 uh, is very less, right? If you can make that, like if you can know half probability of failing, and then you do 60 tries, that's fun idea, and that's the main idea. I have solved one 3000 problem where I used randomization. I struggled so many days for that problem. Now I don't know how to solve that problem, but then long back I remember the problem, this one. And then I know we have to use randomization. So I've used little bit of randomization. I don't know what I have done here. Now I cannot probably do it, but then I have tested. If I don't use randomization, will it fail? And then I removed randomization. And then it failed actually. So if probability of failing is half, greater than or equals to half, and then you try is less than or equals to half, and then you try 60 times, then you won't fail, right? That's it. You have to make sure that probability will get multiplied. Probability of failing will get multiplied. So CF analyzer, they are almost a palindrome. Maybe they are not a palindrome. So what can we do here? So what should happen after this? What should happen after this? This x can be anything, right? Now this will be mid. After adding this x, this will be mid. And sorry, 1 2 3 4 5 6 8 9. Let me simplify this. B B A B B. Let's just say we have this thing, and then we got x. So now what will it be? B B A B B X. So these two are paid already. These two are paid. Now this A and this B are not paid because we are just maintaining. Assumption is we are just maintaining B's S S B's because most of them must match, right? Most of them must match because N is too big and you can only do something. We are maintaining something like this. Okay, we are maintaining something like, but maybe not exactly this. Then we will see what we can maintain. Suppose if you are maintaining the simplest thing that we are maintaining, we're maintaining everything like this all the time. Then after this comes, how many may not match? What happens? We have more A's, right? Now one A is gone. Means we have three A's matching. 2, 3A's. And then 1B will not match to 1A. We will always have this A not matching to this B. Okay. So we have B. We have matches. We have A. We have B. And we have X. So if X is A, then we can swap this B and that X. We can do it. Why am I trying to maintain them straight is because after once moving forward, this thing will happen, right? If X is A, because here we have yes before that. So we should also check if S are aligned or not. Why? Why are we trying to maintain S in a line? Because after adding a character, everything shifts a bit. When everything is shifting a bit, if it is AB, many things may not match, right? That says we have to maintain B's in a line, A's in a line. The shifts cannot happen more than many times because whenever a shift happens, we lose control here. We lose. So I think probably this is what we maintain because if you maintain something else, it's not possible, right? If X is, see, after swapping these two, A's are again still in line, B's are again still in line. Okay. So we have B's now, we have A's now, we have B's now. It's again a palindrome. Now, now, if you get even, now this is odd. So now if you get y equals to a, can you maintain? Can you again make it like all all even, all odd? Because this is odd, right? This has two things now. Can you again make it perfect is what we have to see. Okay. B's are already matching. So if it is A, you can swap this B with this final Y and you can make them B B B B A A A A A A A A B B B B. You can do that. Swapping this with this. I'm trying to see two steps because not just x equals to A is sufficient. We have to handle the next even thing too because that's how the cycle is repeating, right? Odd even. We have to be able to make a permutation because we're trying to see if we can get back to this and are able to get back to that. If y equals to b, can we get back to that? Here we can't. Here we can't. Because if y equals to b, so we can't always maintain this. But still, we have to maintain something where most of the things are in line. So maybe seal of b's, floor of s, seal of s, floor of b's. Let's say we maintain that. Let's try to see the worst case itself. Let's say if you're maintaining this, because we have to maintain many things in a line, that's for sure. Why? We have to maintain many things in a line because when a new character comes, things will shift and still you need more palindromes. Let's say we're trying to maintain this thing. A CF analyzer, is it being fine? Oh, nice, bro. We'll hit 100. We'll hit 1,000 this today then. 1K subscribers. No celebrations. We have Umnik. No I mean, or they're not sending me like money or something. There's nothing here. There's nothing. Maybe you mocks me. How did it looks maxing? I'm just joking. Yeah, we are following, right? So let's try to think we are maintaining this thing. See, nice. But that's nice. But what about this thing, CF analyzer? Most of the A's should be in a line. That's for sure. Most of the B's also should be in a line. That we know because after one shift they should again match. So I'm just thinking because this is not always possible. I'm thinking seal of B's, seal of A's, and then seal of A's, seal of B's. Now if we have this thing, let's try to think the problem again, the same thing. if you have this thing, we should see if we can proceed further now. Okay, let's do the same thing again. Let's do the same thing again. Wait, instead of floor of A's, I'll try to make floor of B's, seal of A. Why? Because when a new thing comes, this A becomes. Wait a minute. When a new thing comes, this A becomes that, right? So I think the previous thing is better. When a new thing comes, I'm just wanting to make sure there exists a A. Okay. So now we have seal of B's. I think still it's being simple, right? Because after each step, we should be maintaining a palindrome. After every odd thing is a palindrome. Every odd thing is a palindrome. So let's say if every odd thing is a palindrome, can we? Okay, we have two questions. Can we come from seal of B's to floor of A's to palindrome? And another question: can we go from palindrome to seal of B's and seal of A's? So if we have seal of B's, floor of A's, seal of A's, floor of B's. So which is like B B B A A A A A B B. So if we have X, if X equals to A, if X equals to A, what should we do? We have B B B A A. A is in middle now. A A B B. Because this was odd. Here, almost everything is matching. In one operation, can you make this a palindrome? And then we can maintain this. Because this B should come into middle. But then we will lose structure. So if that B comes into middle, what happens? A B B A A A A B B A. We can make it palindrome, but just remember that these B's are many, these A's are many. Just remember that those B's are many, these A's are many. This A is only one. This A is only one. But then with this, you cannot go back to seal or floor, right? With this, you cannot go back to seal or floor. So what should we be maintaining? Wait a minute. Why did I do that? Here, just swapping these two is enough, right? Okay, here just swapping those two is enough. We have BB, yeah, yeah, B. I don't know what I have done before. No, I'm right. We should be making this palindrome. So we should. So we must remove this. So it will be ABB, A, BBA. So I think this is also not a great idea. Thanks, Pradeep KR. Yes, CF analyzer. And like after that, again you make it. So what do we maintain at each event step so that we maintain a palindrome? Again, you're telling something to add AB, BA, BA, AB. If you solve this, we can stop the stream, right? So here it's a bit problem. If you're maintaining this, it's being a bit problem. What if I maintain floor of S, floor of base, floor of S, seal of S, seal of base? So what do you mean? You have ABBA, but then after one operation you should go to palindrome. But then when you add one more thing, again you have to come back to the same thing, right? I get it, I'll try that. But then let's try to finish this. If you can do this, it's good for the stream. We cannot ruin streams, right? We cannot ruin content, right? People will unsubscribe. So we have to make streams a bit valuable for later viewers to people that watch it later. So we have to solve this thing. And then we go to D. Lead code D. So what do we maintain? If we maintain this, can that be solved? Would that help? BBB? BB? Yeah, yeah. Yeah, yeah, yeah. BBB. Right. So now X came. After X comes and X is A, this is a problem. If X is A, now B should be the palindrome. The previous one is better than this. And B should go to middle. And this B should go to middle, but then it won't be a palindrome. I think, yeah, okay, there are four types. So, let's try our initial thing only. Here, what should we do? What about this? Floor of base, floor of S, AB, or BA, floor of S, floor of base. Because we are needing a B in the middle, right? So let's just me see for the most obvious things, okay? Most obvious things I'm just trying, just based on the fact that many things should be in a line, or this thing. So let me try this thing. For odd cases, if I maintain that, BB, AA, BA, AA, BB. This, let's say now we have an X. So I think I will maintain it like AB. If you're maintaining this, now we have an X, and if X is A, then what do we do? BB, AA, A, B, AA, BB, A. So this is that, right? Now I can swap and make it BB, A, B, A, BB. I can swap these two and make it that. Okay. Now we're testing this thing. Now we're able to make a palindrome. Now BB, A, B, Y. If Y equals to, if Y equals to A, Can we go back to AB is the question, right? No, we can't. If y equals to a, we have to swap that a with that a should get inserted here. Can we do only one swap? So you have a palindrome, and then you add two characters, and then you still need a palindrome. So how do we maintain them? Yeah, 1 minute. Here I cannot make it AB, but can I make it BA? If this goes here, if this swaps with this, maybe we can make it BA. BBAA. I will listen to you, bro. 1 minute. BBB. AABB. We can make it that. We can make that this. If y equals to B instead, so now this will become even, right? If y equals to B, you are back to BBB, AAA, AAA, BBB. I'll listen to you for sure. Thanks for speaking. Thanks for being there. Okay, we can't get to AB, but can we get to BA is the question. We can at least come back to BA. So, but then this is AB or BA. This is our structure. So let's see for at least AA. Okay. If x equals to B, I don't know if it falls recursively or not, but let's try to verify very quickly. If x equals to B, what happens? We're seeing it for BA, right? If x equals to B, swapping these two works. And then we came down to a palindrome. Now if y equals to A, or y equals to B, we have seen this case already, right? If that shit is a palindrome, we have seen that case that we can come back to nicer things. We have seen that already. Maybe BA or AB. Sometimes here AB is not possible, right? Here, if y equals to a, you cannot make ab, but you can make ba in between. So this is again possible. If y equals to b, if y equals to a, swapping these two works. Y equals to b, saw already. Both are 8. When both are odd, we have seen this already. When y equals to a, both are even. And we can just swap this and this. We can make BBB, AAA, AAA, BBB. So now we're able to proceed when it is BA. Can we proceed if it is AB? Is the only question we have now. I think for BA, if you're able to proceed with both, I don't know. Let's verify. Yeah, it plays. Uh, Last second character. Okay, if middle character is equal to last second, then swap. But then what's the structure are you maintaining? Can you say me what's the structure are you maintaining for even length things? Is it just can B and A keep coming and going? Can that happen? Even I noticed that the middle character. Can you tell me that structure? I mean, whatever you have done, you should be able to say the structure, right? Okay, after even things, what you maintain, how will it look like? I will read that. I have read that too. Middle character plays a major role. That seems right to me. Uh, yeah, I have said all these things long back too, right? If you see here, middle element is getting decided because odd length decides middle element. That's why when even wait, let me once verify this one thing, and then I'll check further. So for BA we are able to proceed. What if it was AB? What if it was AB? If x equals to A got added, then what do we have? So that's the problem. We cannot proceed here too. We need two swaps. 1 minute. If it was AB, we can do this, but if it was BA, we cannot do that. Say it again, bro. I think you may be right because they need not be in a line. I think they need not be in a line. So if added two characters are not equal, to swap the added characters. Okay. What about the middle things? Are they equal? What about the middle things? Are they all equal? We are maintaining a palindrome, but then when you add two characters, it shifts, right? So let's say we are maintaining AB, 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 and then you add two characters. I'm trying to use whatever you're telling. If it is AA, so let's say this is what we maintain. Okay, AAA, AB, 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 AAA. So let's see if you're. I mean, I won't do case files. I'll just see them instinctively. Like if you're maintaining AA, BA, 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 smaller things will alternate. Bigger things will try to be like this. Okay, let's say if you're maintaining something like this, then if two things came, let there be AB. Okay, if you're maintaining something like this, when one thing comes, can we make it palindrome? If it is not already a palindrome, I think that structure works, bro. I think the structure works. A, B, A, B, A, B, A, with the additional constraints that we always have number of A's on both sides almost equal. With this, we can proceed further. I think this works. This always works. So just think of this. Instead of going case wise, it is A, B, A, B, A, B, A, B, A, with the constraint that number of A's on both sides are almost equal. Okay, let's say this is our case. Whenever whenever odd whenever odd, if A is even and B is odd, means we will have even number of things. We have B, we have even number of things. Probably we maintain this because all of them can be made equal, right? Perfectly. If A is odd and B is even, then we probably maintain because it's odd, and then we have BA 4A's. So how does this go? Now we probably need A to be in middle. So when N is odd and B is even, we have this thing, right? So even then it will be equal. Even then it will be equal. Because if you are trying to maintain them as equal number of things, we have middle thing and it will be equal. So whenever odd, it's being equal. If you can maintain this thing. So now all we have to think is, can we maintain such a thing? Alternate pattern, try to make these things almost equal. Alternate pattern, try to make these things almost equal. This is what we want. If you can maintain this or not. So now if you have this, let's say you have this or this, right? This or this is the pattern, right? The biggest thing is even, biggest thing is odd. These are the two only possibilities, right? Let's say you have A. So now what should you do? A. Just keep it like this. Almost equal works. Let's say you have B. B A B A B A B. Now 4 5 is almost equal. 4 3 is also almost equal. So what I will do is, I will try to insert this. Okay, now it's being a problem. Okay, I'll try to insert this with this. I'll choose this and swap. So A will be there. B A. 3 and 4 are almost equal. 3 and 4 are almost equal. So if you can make things almost equal, so we have to see one more case. I think this is being possible. That's what we have to see. See, see, after this thing, so you either have two things like this, bro. A, A. So when even, you either have this or you have both of them being odd, right? This is, or you have both of them being even. So when even you have these two things, both of them being even or both of them being odd. Okay. So you have this odd palindrome in between. When even here both of them are odd, right? Here both of them are even. So you always have this, let's say, okay. You always have this. When size is even, both of them are odd. Both of them are even. Okay, you always maintain this thing. Now here, if you get a x equals to a, you're done. You need not do anything. If x equals to b, you can swap. We have to insert this there. If we can insert x here, then we can do. But if we are swapping, I don't think we can do. But let's say we have this. Can now we do. Let's say we always maintain more number of a's on this side. Maybe that's possible. Then when you have b, we can do that. When we have a, we have to swap this a and this a. Again, you have to swap this. If you have more number of a's on this side, whenever a b comes, well, I don't see why can't we do it when there are more number of a's on this side? We have b here, right? Yeah, we just can't. So let's say when there are more number of a's on this side, we have a b here. Swapping these two will work. Swapping these two will work. AB got added and then A. If x equals to A, we are having more number of A's on this side, but then that's too many A's. So can we send one A on that side? We can do that. We can swap. You can swap these two, B and A, so that we have A. But then again, number of A's on this side was reducing. See, it's being very weird. Like, if you're not very weird, like, if you can have more number of A's on this side, then it's possible. So when size is even, we want this. Okay. If X is A, 1 minute, 1 minute, 1 minute. This is just in between, right? Now, what am I doing? When size is even, one, two, three, odd, odd, and then you got one, you have to make this a palindrome. Is this a palindrome? No. Why or how? Okay, this is a palindrome because you have no. After you swap this, you will have 5 A's on this side. That's not a palindrome. How to swap to make this a palindrome if x equals to A? Maybe you can swap this with this. That's what I did. Wait, this can be made a palindrome. If x is A. If x is B, for x equals to A, we need more A's on this side. For x equals to B, we need more A's on this side. What the fuck? Guys, we are stuck here. It's too bad. Say, what's the answer? Maybe is this also too simple of a structure? What about this thing? I don't know what am I doing, but I think this has something better. The problem I face here, I think will be reduced here. Here, whatever we get, we can swap them. If we get A, these two things being almost equal. So these two things being almost equal. Okay, this is even now, right? When both are odd, it looks like BAB. I should not have tried this problem. If this is A, can we proceed further by moving this? See, if we can do insert, that's good. But then if we can't do insert, we can only do swap. Can we? Can I swap these two things to make them equal? Can I swap this B here to make them equal? Can I swap this A over here to make them equal? See, remove and insert is different from swap. If you can do remove and insert, it can be done. Guys, I'm leaving. It's not about rating. I mean, there are so many possible patterns, but we have to think and see in which pattern swap and swap can help us well. We have to think that. Yeah, there are so many patterns possible. One may work, but we have to think. I'm not leaving before solving this problem. Fuck. What's the pattern? You can reform with just one swap. When x equals to a, you should make this a palindrome with one swap, right? And what is odd here? That should go to middle. I think this is even worse. I don't hate lead code. I just don't know it much. But we have to solve this problem, guys. Think some pattern would work. Just make statements about the pattern first, not randomly try many things, but make some statements. After you get something, see, I'm not again giving importance to this thing that I gave initially. That makes mid element to change. That mid element will decide that should go to there, right? See, I'm not giving importance to this. Mid must change many times. So this one seemed very nice. Here the only problem was with BA. The only problem was with AB, you're able to come to BA. With AB, you're able to come to BA. Wait, why did this fail? Yeah, it fails because if you get A, you cannot proceed further. Because if you get A, B is odd. See, if you can insert, it works. But if you cannot, We tried everything. See, let's give more importance to structure. Okay, it's very weird. Like here, sleep, guys. Don't view. How the fuck can we solve this? We have to make some statement after every event. It may be needed that mid must swap. Should I end the stream? Yeah, there should be at most that things to make it anything we want. Let's just see the all cases like you have told me before, okay? After adding two characters, what happens? After adding two characters, what happens? Before, what are the pairs we have? See, whenever we were not able to solve a problem and then we solve a problem, we can analyze what mistakes we have done, what better we can do, such things. Okay. So let's say this is our current palindrome, odd palindrome. And then we have added x, y. and then two swaps have happened. One swap have happened here, another swap have happened here. So now the pairings were this or equal, this or equal, this or equal, these or equal, these are equal, right? Let's try to see logically whatever we can say on this thing. And after this, what do we need to be equal? And after this, we need 1, 2, 3, 4, 5, 6, 7, 8, 9. After this, we want these things to be equal, these things to be equal, these things to be equal, these things to be equal. You can do two swaps. What happens with a swap? What happens with a swap? What happens with a swap? You can connect this thing to, let's, instead of changing characters, let's see, like maybe you're moving this to this, right? You're moving that pairing to this pairing after a swap. So everything changes. This goes to this. So let's say this is the final thing. Okay. What is that? What is that? What does that say? Let's say something is unchanged. This is unchanged. This should be equal to, let's say, whenever we are swapping, we are not changing characters. We are just changing edges, let's say, okay? So this is what we know. And then whenever we swap this with something, we are saying that I don't get it what I'm using. Am I visible? We will solve this, bro. We are not leaving until we solve this. I am not getting anything, but still, let's try. I have to solve at least one higher rated problem in a stream. I never done that like before, and it becomes worse if I can't do it. So, what does this restrict? Like, what does this restrict? After this, what should happen? Let's say only four things might have moved in, right? Only four things might have moved in at max, right? At max, only four things might have jumbled. And after that, what do we need? We want these things to be equal. Let's say this has not moved at all. This has not moved at all. Okay. What does that say? That, let's say we have all these things that have not moved in, and here we have all these things that have not moved in. What can we say? Previously, now two things have been added. If it is one thing, that restricts that most of the things should be in line. So my logic when I thought, okay, most of the things should be in a line was not that correct. Most of the things should be in a line because even this seemed to be working very well, right? Why? Because most of the things need not be in a line because we want palindromes only after two things, right? That's why most of the things need not be in a line. So that logic here itself, if we were very careful, okay, then we would have said, okay, need not be. What should have actually happened? If all of these have not moved, okay, and we have its complement on this side, all of these have not moved, then now this should be equal to this should be equal to this. But before this was equal to, all of this hasn't changed at all, right? So before, when size was too less, this was equal to, this was equal to this, but then what was equal to, what was this equal to when size was less? When size was too less, this was equal to two things before that, right? So what, for whatever the things that have not moved in, let's say these are all of them have not moved in. So this is a palindrome when two things have been added. Okay, so this should be matching to this, but when those two things have not been added, this should be matching to two things before this. Okay, so this are equal, and this and two things before that are equal. So whenever it is odd, when things don't move, that makes all these things are equal. That only makes all these things are equal, and also probably all these things are equal. That says the restriction is most of the things should be same. When you look at, and what else can we say? If this is even, can we say that this also should be even? No, in the first half, yeah, if this is even, also this should be even, and this should be even. So almost all even indices should have same thing. Almost all odd indices should have same thing. That doesn't move. Okay. That just says alternate. I know. I should not eat these many chocolates. Should I end stream? So this is true. This is true that it is true that we want, so it must happen that most of the things that doesn't change at all, because with two swaps you cannot change most of the things, right? So most of the things that doesn't change at all must have. So guys, hey, so we made some progress logically by trying to look at this thing. Okay, we made some progress logically because we can definitely find if only four things are getting changed, these two things are newly added, and two swaps might have changed four other things. Okay, even with four things, we can find large chunks of pairing that doesn't have anything, right? We can find at least n by 4 times of pairing that doesn't have anything. And if you observe that, now this pair, this should be equal. Both of them are even. And all the odd things should be even. So that's what it says. So all the odd things should be even and all the even things should be even is what it says. For most of the things, that doesn't change. Means it's definitely alternating. We want it to be alternating for sure. That's definitely true. Whatever doesn't change, if you look at these two things, they should be alternating. Like we are trying to also see this and this that hasn't changed at all. Okay, we are looking at them together, then we can know all these and all these are same and all these and all these are same. That's why the patterns that I chose, this is a bad pattern. All yes, all b's, all b's, all yes, this is a bad pattern. Why? Because when things become long enough, you cannot have some big substring that has A's, B's, or B's, yes, that's wrong. So this is definitely wrong. Right. That's why and then I kept AB here. But then that kind of thing doesn't work. And then the extension was alternate. AB, AB, AB. That seems to be working because that's the only restriction you have. AB, AB, AB is not a possible working pattern, but it is something that's tight. That's what is allowed to have. Okay. But what happens when you add now? We're looking at things that don't change. Oh, we have already applied that after adding that forces these things to be equal. What? Did people unsubscribe? I'll try, bro. Because if A's are too many, B's are too many, and string is too many, alternate must be included in the pattern. Right? It must be included. Because A's are too many, B's are too many, and then we have some big string that must have A's, that must have B's, because only four things are changing, right? If that's having A's and that's having B's, alternate is the way. So alternate is definitely there in the pattern. Okay. So what are the patterns possible for alternate? I have seen them, right? I have tried them. I've tried I've tried these things, because this will only get connected to this, right? So even though these are odd, they will only get connected to this. So that may seem. I tried maintaining this pattern. This seemed like very correct because B is the only restriction, right? Once you add two things, things change from two things to two things. So that seemed right. See, but then why was it not possible was very small reason. If I can just insert, it works. But swap, making it not possible. See, here I got A. Okay. Now both of them are odd. Okay. A is even, B is odd. So here A is even, B is odd. When we add A, can we make it palindrome? Where is mid? We have to change mid at sometimes. Right. Okay, here it's a palindrome already. You can see, so the pattern says pattern most likely should be like A B A B A B A B A B A B. Okay, and then something like this. It should be just something like this, right? Because most of the things that doesn't change should be equal. But then if you are having in between, when they shift, when that shift, it makes like all of them should be A B too. So what should it be? This seems like the most correct pattern, right? Yeah. But then we are not able to proceed with that. What was the problem with that? Let's see again. Maybe I'm missing something. So if you have this and then A appears, can you make the pattern again? And then A appears. Okay. And then B appears. You can make this. But when A appears, what I will do is I will make it A, B, A, B, A, B, A. With this, I have more number of A's on this side. Okay. Here, when B appears, again more number of A's on this side. Whenever odd, we are able to always make more number of A's on this side. But whenever odd and A is odd, and then B is even, now if you get A, we can swap these two to make more number of A's on that side again. But why do I need more number of A's? I'm just assuming that. Why am I having more number of A's on this side is whenever a B gets added, we have to retrieve A's from this side, right? That's why. We have to retrieve A's from this side because when B goes there, some A's should be able to come here. That's why I'm trying to maintain more A's on this side, okay? If B comes, now what should we do? We just swap these two things so that there are again more number of A's on this side. But then we want much more number of A's probably, not just more number of A's. Right. Wait, 4, 9, 6 comma 3. Damn, that's too many. Wait, what did I do here? I moved this A to this here. So it becomes 6 comma 3. Or I could have just kept it. Wait. If we get B, so we can always have more number of A's on this side. Either too many, instead of 4 comma 5, we are maintaining 4 comma 5, we are maintaining 6 comma 3. Maybe fine. Plus 2 minus 2 is all what we can do, maybe. So we are always able to have more number of A's on this side. Okay. Whenever even. Whenever even, odd, from odd, we are able to go to more number of A's on this side. So now whenever it's even, whenever it's even, you have S, you have BAB. Let's say you have even number of S, then B's also will be even, right? If B's are even, there will be an imbalance for sure. Because B's are even, so in between odd, so there is an imbalance and we have more here. Okay, we have more here for sure. Now, whenever it is odd, we know the pattern already. Either this will be the final pattern or this will be the final pattern, right? So that pattern is fixed. So we have to see if A comes, we are done. If B comes, can we make the final pattern? Can we make this a palindrome? We need too many A's here. Otherwise, we can't. We need too many A's. If you have, when B came, B should be in middle. Is that happening? If you have two A's here, then we can do. Wait, is mid satisfied? Mid itself is not satisfied here. So this must be moved. This must be changed. Right? Mid must be changed. Mid should be B. Wait a minute. Here mid should be B. If it is A, so whatever the size, I'm not applying all the points I got already. I got some points, right? Mid should be changed. See, after adding these two, mid must be changed sometimes because, okay, also that is a point. Also, that is a point. After adding these two, based on this, based on this, mid should be changed. So even mid must be changed is a point. Based on this, because if it is A, that makes mid value to be A or B, depending on parity of odd or even. So even this is gone. So what should be the pattern somehow? Because we have to change many things. And I mean, we cannot do much. Still, we are not able to find the pattern. We cannot do much. My head is hurting. So here, swapping these two seems like working, but then we lose our pattern, right? A, because mid must be changed. B, wait a minute. Yeah, B, A, B, A. But how do you maintain these two already always the same length? As you keep moving, so mid must be changed many times. So what pattern should be maintained so that we are forced to change mid many times and still it works? What is mid? Odd number or odd length, odd values, right? Odd values. You can be changing odd number of things to either A or B, and still you should be able to make them work. Okay, I've changed it to this. Now it's odd. Can I change it back immediately to again another pattern? I'll just think of that. So I somehow got this. So now, if you have x, if x equals to a, see, I am struggling because I'm not able to solve well. But then we have to use more logic to get some statement, and then use that statement to solve the problem. We should not randomly try like I am doing. Okay, if you can follow steps correct, somehow problems won't be too difficult. Like I'm doing it. So now we have to correct this shit. Okay, we have to correct this thing. If it is b, if it is b, how the fuck can I correct it? I think this is best somehow. This seems to be the best one. Alternate, same, alternate. But then this is more complex, right? This is the only thing we left. So from here, AB. Let's collect. And then yeah, everything else is same. From here again, we will collect as much as possible and then everything else is same. Okay. Can we make sure that sizes of these two things are almost equal as we proceed further? Let's say sizes of these two things are almost equal and then we got a B. Then it's probably equal. But then if they are not equal, but then if this becomes plus 2, maybe we can change this B to here by swapping with in between too many A's and then we will have them equal. Okay. But then what if it was A, then we can just move that A inside and then bring the B outside. At this rate, I can never become legendary grandmaster. I'm just joking. I can never become grandmaster at this rate. Is this the solution? Can I see this well? Can I see this well somehow? Can I challenge this pattern? Okay. Let me take a string. Okay. Online palindrome. Name sounds very well. We have to keep making palindrome, palindrome, palindrome. I don't think 99 can help us somehow because maybe it's just to get scare people. I mean, no, 99 cannot help much. But if this is also wrong, then let's assume we have surplus S. Yeah, attitude adjustment. But then, whenever this is even, sometimes we must be changing. Sometimes we must be changing mid. How do we handle that thing? How do we handle that? So let's say you're maintaining that, okay? And when it becomes odd, let me just have A B A B A A A B A B A. So we have odd number of A's, right? So if it becomes okay, or I'll make it like A B A B A. No, I want odd number of B's. Okay, odd number of B's, odd number of A's. This is one of the worst cases we keep happening. We keep having. If this is B, okay, if this is B and if these two things are not matching, then it seems we can do. Where is mid? One, two, three. I think this is mid, right? What is mid? Six. This is mid, right? This is mid, right? How do we handle these things not matching? Let's just say whenever we are odd, can we go to even and then come back? Maybe we need not face this case at all, right? Let's just see that. A, maybe B in between. So this is a valid thing because we should be changing mid to A or B as we like. So in this case, can you add two characters and still go back to this is what we want. In this pattern, can you add two characters and still go back to this pattern? Because this is a valid pattern. This is also a valid pattern. Because you must change mid sometimes. You must change mid sometimes. What are other valid patterns? BA. Yeah, let's just see this too. If it fails, it fails. We must have palindromes at each odd step. See, it's true that there must be so many BABAB in pattern in that we proved with logic that this must happen. AB should happen. But then this seems not working. So I'm trying for this thing. So if these two are the patterns, can we come back here after adding two things? Can we come back to this pattern after adding two things? So if you had B, if x equals to B, so let's say if AB, we are adding AB. Can we come back here with just two swaps? If you are having AB, okay, after adding AB, B should again be in the center, right? So maybe after adding AB, what I will do? I'll do AB, A, BA. I'm swapping this with this. But now when B comes, what the fuck can I do? I keep losing my mind. Where the hell do they go? But there's a... I'll just keep it like this only. When we get A, instead of changing this right now, I will change. Fuck, my Sunday is ruined or what? I am not doing anything else. See, if you're getting stuck like this, you will get stuck in contests too. Contests too. It's a bad habit. It's a bad habit to have. What if you get stuck on an easy problem? That's what I do in contests. See, we must change this at time. But then can we recover in even step is what I'm thinking. So if you have AB, okay, what can we do? AB, ABA. I'm swapping these two things, okay? BA, AB, right? So I'll swap these two things, BA. So we were able to do. If you have AB, because these things are in even positions already, so we need not worry much about them. Let's say we got A. can just do bring this a b here first, bring that b here first. Okay, now what will I do? So now we have, so now after this some b should go to middle, right? I'll make this b go middle. Should I on light or should I not on light? If you solve this problem, you want to be like me. Otherwise, these are bad habits, bro. They seem to be working. We have a lot more freedom here. But then you have to decide what you do with A right here, not after two things. Is that what am I doing? Is that what am I doing? Because when A comes, I'm changing something else, right? So that seems fine. So A B A B A A B A A B A B A. Let's check other things to B B. How do you handle this thing? I think now there are more number of B's. First here you got, what did I do for A? First I moved this B to A outside, and then so that I'm trying to form the BA extension, and then when there is A, I have moved again this B to there so that it becomes equal. What I have done was fine, not wrong. So here what should I do again? This B is matching. So I will keep it like that itself. Okay, now we have BA. Okay. Because that's matching, I'll try to make progress by matching this one too, because we got a bigger B. Here what I will do, first step what I will do, AB, AB, A, moving this like that a bit. We have three A's, and then we have BA, and then we are having one more B. So with this one more B, we know what to do. 1 minute. With this one more B, we know what to do. We have to swap the middle one, right? So we were able to do this. What if it is AB? See, if you use logic, we know the pattern BA, must be present, right? BA must be present. We know that pattern, but then things are getting added in the this side. So if things are getting added this side, shifting this seems easier. Shifting BA seems easy rather than shifting this pattern, because when B comes here, shifting this seems very difficult because shifting this needs more number of A's here, because if you get A, you cannot shift some B from there. You cannot, I think if you get B, it was not easy to, it was like I need more number of A's on this side, because if I try to shift this here, number of A's will be reduced by 2 each time I do that. But then here, without changing much, we were able to make things forward, right? We were able to move this B forward without changing much of the things, much of the other things. So maybe this pattern is being better, like B B B B A B A B A A B A B. So if you guys see, suppose let's assume that this is true. It may be wrong, but just arriving to this pattern itself is not that easy. And this pattern is not too complex. This pattern is simple. So you guys should be trying, should keep trying always, so that you should not think some complex thing comes in between, some high level engineering level mathematics comes in that, so that you know you cannot try it at all. Okay, it's still tryable, it's still in your in your scope. Let's see if we can extend. We have many other patterns too. We have patterns starting with B instead of A. We have even for this, even if you assume A equals to B, we have patterns starting with B instead of A. But starting doesn't matter much, I think. And we have to code this if it's correct. Let's see if it fails in the final case, which is BA. Maybe it fails here. That happened so many times in the past. It was looking like this is fine, but then the below thing has failed. So BA, BA, BA. This B is already matching, so I won't do much. That's what I have done before too, right? But instead, because the B got extended, I will extend this too. AB, AB, what will I do? AB, A, BA, 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 B. Now we have an A. So now what do we do? It's already matching. We need not do much. We have our pattern, we have A in between, all good. Even here it was the same. It was already matching. We are all good. Should we just say this? And then we have to code. How the fuck can we code this shit? What are we trying to do? We are trying to always make this lens almost same. We're trying to make this lens almost same, and then we're again trying to set them up. If these lengths are equal here, after adding, because it's odd, lengths are equal. So let's say this thing. Can you hear me calling? Am I wasting time? What was that song? That's a bad song. Should I sing in between? That's verse. Okay, we have A here. A is not matching. So what do? We simply shift our thing. Okay. A. 5 A's are there. We simply shift this B and this A. Then what happens? A, B. See, we are following, we are building upon the previous thing itself, because we should not change indices. We are building upon the previous thing itself. This should be B. So I'm bringing that B here. Okay, do you get what I mean? Do you get what I'm doing? Let me show you properly. So I'm bringing this B there. Okay. And then we have another B. So now what should I do? This B just goes in between, right? That's not in between. This is in between. See, the fact I have logically proven that the pattern must have AB. We have proven that thing, because if only four things are changing, there will be long things that have not There will be long enough things that have not at all changed at all from the previous thing. From the previous thing, we get to know that all these even things should have same thing, and all these odd things should have same thing, and then I'm building up on top of that thing. I'm making sure when I add something, if this is here, this should be B. If it is not B, I'll try to make it B. Okay. If it is, we are able to build this. Can you hear me calling? Am I wasting time? So now, A is false, A is bad, right? So we do the same step as before. We do the same step as before, and then again we got an A. Now what do we do? It's already matching. We need not do anything. Let's say BA. It's already matching, but we have this bigger, right? We have this bigger. It's matching, but this is bigger. But we cannot help it. Sometimes that will be bigger. We cannot help it. Sometimes that will be bigger. But then we should be able to just leave it like that. Maybe just leave it like that. If we face a problem, then we can think of it. Now we have A. But then after having that A, you have this B to go to its middle place. So you just move it. Good. But what if you get B? What if you get B? Then again you can do the same. Probably mid will have A, right? Middle things are A, right? Maybe you can just swap the A with this B. Here we have swapped this B. Here we have swapped this B. Here we will directly swap. What have we done? Yeah, after adding that, we have swapped this B with there, but here we can just swap because it's again B. We can just swap that B with A. Previously, that was A, so I was not wanting to swap that, so I swapped that. So, is this doable? Or am I hallucinating? I don't know the spelling of that. It's not about string, Satyam. It's just logic. It's just string interactive logic. But did we solve it? Should I try to code to see the complexity? What are the? I'm shouting. I'm shouting. If you think about that. No, no. Let's think. Let's think. Let's make statements about our algorithm. Okay. Let's make claims on our algorithm. What are the claims now? You will maintain. You will maintain ends as ABAB, middle as same. This is one claim. And then the end ABAB uh, must be same. Must be almost same. And what do we do? I think I came to this pattern a while ago, but then I thought this is too complex to work on. I thought this pattern is too complex because there can be A here, there can be B here. But then when I went back and then when I saw all even things being in A is enough. We need not worry. We need not worry about okay, starting with A, ending with B. We need not worry about that. Because if it is even, index will work out. Then I thought, okay, this is simple because I just have to make sure that do you guys are you guys understanding what I'm saying now? I'm saying what I'm saying is I came back to that because I thought, okay, there are too many cases, starting A, ending B, starting A, ending A, and all. But then there are not too many cases. If you can just make sure that, if you can just make sure to extend the pattern, then there are not too many cases. Then there are not too many cases. So that's why I came back. Okay. And I got that there are not too many cases, just even index having same thing, odd index having same thing is enough when I have seen this thing. So logic will help us. Logic will help us understand the pattern. Logic has helped me to know for sure there is AB, AB, AB. This we came here logically. When we are trying randomly, when I made a careless mistake, assuming that A's can be straight, that costed us a lot. This is a careless mistake. Like when you're telling A's can be straight, how? Why do I say that? Did I feel that? Like we should not be like that, right? We should not just use induction. We should know very well. If you are very careful, we know why exactly do I think A should be equal. The only fact we know is after two operations it will become equal, right? So after two things, if it is getting equal, if it is becoming a palindrome after everything, then line is good. If it is becoming a palindrome after every two things, then only even indices should be equal is the fact, right? Is the thing you can say, right? So we should be very careful. See, this is carelessness. This is carelessness. Assuming A should be straight is carelessness. Trying to apply logic is best. I thought this will become too complex to do, but then it's not being too complex. This one is not being too complex because if you can always make even index, if you can just try to extend the pattern, that will work out. Okay. Do we have viewers? I'll go Susu and come. Let's in third golden rule is implementations are simple. So we should simplify a bit more before implementing. Okay, because I'm making claims on algorithm, right? So if we make those claims, we understand. See, why am I telling proofs are simple, implementations are simple? Is it's like they will align. You can always make them beautifully. Like you can always understand the problem and you can write code in a way that looks like the problem that tries to clearly show what you're doing. Do you get what I mean? Like the video, guys. 29 likes isn't enough to sit straight for 4 hours, right? So let's call our first character A. Okay. Let's call our first character A. Okay. This is without loss of generality. So now we keep getting some yes. We are fine so far. The first time we get B. Now we assume that. Now we assume that we have. Okay. Now we assume that we have our pattern already. We have starting with. I want to fix things. I want to fix things. I want to fix starting with A B always. Okay. So wait, do we have some conditions like, do we have some conditions that will make the problem fuck up again? Like this thing should be bigger always, this length should be bigger always, or something like that. Do we have that? Did I assume such things somewhere? No, I haven't assumed anything. I covered everything, but starting from here, I covered everything back. But starting from here, I covered everything back. So that's a good thing. From here to here, we were able to come back. So that's a good thing. So I haven't assumed anything regarding the even things, right? Regarding the odd things, I haven't assumed anything. Starting from equal things, I was able to come back. Starting from equal things, I was able to come back. So this is the S that exists so far, right? So these are the A's that exist. Okay. So here odd. So these are the A's that exist. Now we are getting B. Okay, and then here. From here, let's start. From here, let's start our whatever that thing is. So now we got an A. Now we got a B. Right. So we want to start the pattern somewhere and then we know how to proceed further, right? So we want to start the pattern somewhere. So because these are all A and this is B, I think the first time this happens in an odd step, whenever these things are odd, whenever these things are odd, the first time it happens B, then the pattern is, then the pattern is 1 2 3 4 5, right? Even things having B. Okay, but if it happens when like this, when odd things are there and then A comes and then B comes, now the pattern is odd things having B. See, we haven't worried about what if too many B's happens. We have to worry about that too, but I think that will work out somehow. That will work out. Okay, let's just check that once because we have to implement everything, right? See, now you guys should know that the people, higher rated people like LGMs who solve these problems in contest, they try much harder than you people. They don't know some topics that makes them solve this. Are you able to realize? Are you guys able to realize how hard they would try? Like how not just hard, they try logically. They try to use logic. They try to say what they can say. They try to see the problem as a whole and then try to see, okay, what can I say? What obvious things can I say about the structure of the pattern that I may guess? They're trying to say logical points on the structure of the pattern. So let's see if you can. If you get too many B's, what do we do? Let's just take this case itself. If I keep getting B's, where are too many B's? BB. Okay, here if I keep getting B's, if I okay, we have this now. Wait, what the fuck is this? We have this A B A B A. I know what to do here. I have to swap this B with this, right? So I have to swap. Wait, why is this not? Oh, okay. I have to swap with this B with some A, right? What is that A? Okay, this A. So that works. That works. So now if we are getting B again, now I will say this as, if you are getting B, it's fine. We are just extending it. If you are getting again B. Now I will try to go and find a in middle and then replace that with this thing. So we always want the pattern at the end. Okay, we want the pattern at the end and then we can make equal things from the middle. So how are we proceeding? If something comes like this, we are fine. We won't do much. I think I think people are subscribing just to chat because I kept this subscriber only mode. Only subscribers can chat. And then they'll just leave after that. What's 1K? Can't I see it exactly? 1002 subscribers. Let's see analytics. Yesterday video it is saturated like my rating already. This video only got me 2 subscribers plus 2 subscribers. Yesterday's right. No one's watching that yet. So that means my subscribers are actually looking at my videos. So no AI will give us some bullshit topic ideas. Coach Jeff starters, Teja Smart's rapid solution walkthrough from zero to competitive. My honest CP journey. New video. The fuck, I'm not an expert. Know your shit. AI. Unmasking Teja Smart. Should I remove my clothes here or what? AI assistant problem solving. My Codeforces experiment. Popular topic with your viewers. What the fuck are you people watching? Popular topic with your viewers. Are you guys watching AI assisted problem solving my Codeforces experiment? Is that true? Okay, I got an example. A, B, right? I will make A and then I will make, yeah, let's not distract, let's try to get back. And then I will make AB and then I will make, so now ABB, right? ABB, ABB. This B is not in right position. No, this B is in right position. This B is not in right position. But what the fuck? Why is it not working? A, B, B. I know what to do, but what's our algorithm that says you do this? We have A, and then B is the right thing, and then this B is not the right thing, right? It's like two B's. How did I handle two B's before? It's like all S, two B's case. Wait, did I not solve the problem? Okay, all the A's and two B's, what happens? I'm scared. Okay, one B came, it's in its right place. It's in its right place. And then BB, right? So let's see. Because it's in its right place, we don't do much. But here we have too many B's now. Right, so what will I do? I will move this B before. That will become A, that will become B. So now we have almost equal things. And now we got a B. So what do we do? Because we got a B, there must be a middle A. We must replace that middle A. This is the middle A. I'll replace that with, what the fuck? There is no middle A. 1 minute. 4. Okay, this is wrong. This is wrong. This is the question because we want. So this is the question, right? This was the question. This was the question. Because we want, or we are starting from odd length. So this was the question. We got a B. What do we do? It's in the right place. B's are not. B's are almost matching, so we don't worry much. And then we got another B. So what do we do? A B A B A A A A B A B A B. We are not doing much. We got another B. We have to keep it in the middle place because whenever out comes, what we have to do, if it affects in the middle, we have to change the middle thing. Almost equal, right? If it's affecting the middle, I'll just replace it with that middle thing. Done. So now what? How to do? So how to do A B B? How do I handle next B? The case that guy gave. How do we solve this case? Uh, 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 See, this is not that difficult actually. If you realize it again, I'm taking time for no reason maybe. So we have another B. So this is, you have odd number of S. Okay, here we have odd. Here we have yes, zero B's on left side, zero B's on the right side, and then I'm taking this as a right thing. Okay, I'm just taking this as a right thing. So now this is a wrong thing. Okay, whenever this first became itself, this is a right thing, but then I don't know how to initially form that structure. Can I use some logic to initially form the structure? We have AB here. So it is same as this thing, right? B, A, B, B. Now we got a B, let's say. Okay. This is in the wrong place. So what do we do? I think this is in the correct place. So we kept it in there. And then we got a B. Okay, now A is odd. Now A is odd. And then we got a B. A should go to middle now. But then we have a B here. The fuck is this? Hmm. So A should go to middle, right? Why did we miss this before logically? When there are too many A's, even if there are even number of S, how do we handle this thing? How do we handle just this thing? 1, 2, 3, 4. Okay, odd number of S, right? Okay, previously assumption was A was already in the middle, right? And then you got a B, and then you will try to extend this B with this A. So previously the assumption was you will make this with, you will replace this with the A, right? And then done. But if it is AB, AB, B, how do you proceed now? This happens only if there are no too many things in middle. We want to bring an A here. So here itself we should be a bit more careful. Is that so? And you have a B. See, this is an extreme case where, what about this case? A, B, A, B, A. Guys, let's see if you can solve this. Let's see. And then you got another A. You should make this B. So you will just flip that with this. Then, no, I should not make that A. A, B, A, B, A, B, A. You should make this. So this. Okay. 5, 6, 7. So this is a 7 pattern. And then you got A, B or A. Now we have to think because two things we have to think: 7, 8, 9. We have to think for 9, right? Even here, what is the problem? We have odd and then we are getting two B's. This was the problem, right? So after getting this B, can I change something here? It is in its right place. So this is the only case that's bothering us, right? Do we have viewers? I don't think people can see this. So we got B, right? What is mid here? This thing is mid, and that should become A. That should become A. I mean, this should be solved, right? Because ABA. If this is A, what do you do? It's again wrong. So whenever this thing is there and then you get a B, you cannot have that B. You should make it. So let's say whenever this happens itself, instead of this, if I maintain BAAB, is that beneficial? So now when you come BB, what do we do? But then you cannot change these many things in between, right? And then you get another B. But then if you get A now, you cannot change everything back to this A is right. And then you have another A. So whenever you are like this, whenever you get A, after BAB, whatever you get, can you just make it BAB? But if you get B instead, then you make it ABBB. This was failing, right? A B A B A B A B A. This was failing for BB. How? Once you get first B, what do? You don't do anything. And then when you get another B, what do? You replace this A. Replace this A with the B. For that, you want this to be greater than one size. Right? You're replacing this A with B. So middle should be greater than one size. Where all did I apply such a logic? Like where I'm trying to take this thing to proceed further. So that was the problem, right? In general case, I was trying to take this thing to proceed further. But the problem is when that's one, we cannot proceed. That's the only problem. Do you guys see? Guys, I'll end the stream. I'll continue it tomorrow, okay? Is that guy there? Only this thing is failing. Only this thing. Like, if only this thing fails, if this A doesn't exist, that's the only case we are failing. That's the only case. So if the holy waters water down. Mhm. Oh my, oh my love, take a look at the ordinary. You ever seen it? You can have A B A B A B, and then you keep getting B B. So what do? Whenever you get B, you will replace this middle A with B, and then this will be A. That's good. A B A B A B B. This was wrong, right? What was the shitty case that we got stuck with? A B A B A B B B. This is what we got stuck at. Odd and B, and then another B. We just add that, but then when another B comes, we are stuck. Before we are able to, when another B comes, we are stuck. But before we are able to assume that instead of one A here, before we assume like there are three A's, so that when this comes, we are fine, and then when this comes, that will replace this A. But then if that middle thing is small, then we have an issue. So if the holy water is watered down. between this b and this b, we will have odd number of a's always. Why? Because this b and this b will stay in same index, so we'll have odd number of b's. Whenever that odd number of a's in between is greater than 1, we are good. Only case we get stuck is when that odd number of a's is 1. And when do we come to that position? When do we come to a position where we have odd number of a's? When do we come here? Can we never come here? Can we never come here? We will come there. We will come there in some cases. We have to just make sure that we don't come there in those cases. What are the cases where we will come? If b's keep on adding, if b's keep on adding, like, where did I write that? So this is fine, but after this we come here, right? Here, when you replace that b, 1 2 3 odd, right? It is even, it works. So 1 2 3 4 5 6 7 8 9 10. So now if a b comes, we are stuck. So this was our a. If this a had, how do we come here? If this a had, so we are here, let's say, and then we got a b. 1 2 3, and this cannot happen. Okay, let's say we are here. Guys, leave, guys. I will end the stream. I'm ending it. It's too much. Right. So I'm ending it. Let me try later. But what? Just that one case. Is the solution correct? Is the remaining part? Is that remaining part is correct? Does it? Is that correct? So what is the fucking problem? 1 2 3 4 5 6. So let's say this is a valid case, right? This is a valid case. Now B keeps coming. A, B, we'll just keep that. As our algorithm just says, just keep that. And then again B comes. Now what do? We know these A's are greater than or equals to 3. So what do? We move this B to this A. And then it works out. A, B, A, B, A, B, A, B, A. Okay, but now again a B comes. Our algorithm just says keep that, and then a B comes. Now number of A's is odd, and this is the odd place now. This is the odd place, right? So then number of B's is odd, number of A's are odd. So we should make this as our A. So after this, you cannot just keep it like that. You should make this as A, and you cannot have A B here also. You cannot have A B here. You should make this as A. You cannot do that many things right here, right? But instead of this, if you can make this itself as B A B A B, here we get stuck because we have to change these two things. I mean, this thing should become A. This thing also should become A. Maybe this is also wrong and there is some other pattern, then we cannot do anything. Fuck, I'm just ending it. It will just get worse, okay?